Question 25. Non-luminous objects can be seen because they are A. Are polished. B. Are near. C. Reflect light. D. Emit light. We all know that non-luminous objects cannot emit light by themselves, okay? But they're going to reflect light gotten from a luminous object. So the correct option to this question is C, which is what? They reflect what? Light. Question 26. If the relative density of gold is 19.2, the volume of 2.4 kilogram of gold is what? We have the following options. Option A, 1.92 times 10 to the power of minus 4 meter cube. Option B, 4.61 times 10 to the power of minus 3 meter cube. Option C, 8.00 times 10 raised to the power of minus 3 meter cube. Option D, 1.25 times 10 raised to the power of minus 4 meter cube. And we are given from the question the density of water to be 10 power 3 kilogram per meter cube. Now looking at this question, we must ask ourselves, what is relative density? Relative density, RD, is equals to the density of metal or material, or let me say of solid, over what? The density of water, or equal volume of water, right? Now we have given the relative density to be 19.2, so we say relative density is 19.2 is equals to the density of solid is what we don't know, but we have the density of water as 10 power what? 3. Okay, so let's do cross multiply. Therefore the density of solid is equals to 19,200 kilogram per meter cube, right? If you still remember that the density rho is equals to mass over what? Volume. Let's just substitute. Since you are looking for the volume, therefore we can say cross multiply. Volume is equals to mass over what? Density. Is that clear? So let's just put it there. So my volume is equals to the mass over what? Density. What is the mass? The mass is given as 2.4 divided by the density is gotten as 19200. Okay? The answer becomes 1.25 times 10 to the power of minus 4 meter cube. Is that clear? So this is how to get the volume of the material. So the correct option in this question is option D. Question 27. A blacksmith heated a metal whose cubic expansivity is 6.3 times 10 to the power of minus 6 per Kelvin. The area expansivity is what? Option A, 2.0 times 10 to the power of minus 6 per Kelvin. Option B, 2.1 times 10 raised to the power of minus 6 per Kelvin. Option C, 4.2 times 10 raised to the power of minus 6 per Kelvin. Option D, 6.0 times 10 raised to the power of minus 6 per Kelvin. Now, coming to this question, something that will come to your mind is this. There's a relationship connecting the cubic expansivity and the area expansivity. So let's look at it. If you remember that gamma, which is the cubic expansivity, is equals to 3 what? Alpha. And also remember that what? Beta is equals what? 2 alpha, right? We can say that if you make alpha the subject, alpha becomes what? Gamma over what? 3. While here alpha becomes what? Beta over 2, right? So if you can equate both of them, you see the relationship connecting them by saying that what? Gamma over 3 is equals what? Beta over what? 2. So from the question, what are we actually looking for? From the question, we are looking for area expansivity simply by doing cross multiply. So beta is equals to 2 gamma divided by what? 3. I hope that is clear. So simply by multiplying what we have, by saying that beta is equals to 2 times, what is my gamma is 6.3 times 10 to the power of minus 6, okay, divided by what? 3. Do you understand? So we can work it out. Now when you divide this, it's going to give me what? 2.1. If it gives me 2.1, then you multiply. I'm going to have my answer to be what? 4.2 times 10 to the power of minus 6 per Kelvin. Do we understand? So this is how you can solve it. So that relationship connecting the area expansivity with cubic expansivity, and the correct option to this question is option C. Question 28. In a gas experiment, if the volume of the gas is plotted against the reciprocal of the pressure, the units of the slope of the resulting curve is what? We have the following options. Option A is power, option B is work, option C is temperature, option D is force. Now look at it. They said in a gas experiment, the volume is plotted against the reciprocal of the pressure. So that means this is change in y over what? Change in s, right? Then if you plotted volume against what? 1 over what? Pressure, right? It's going to come up to be what? This is volume times what? Pressure, which is the same thing as what? PV, that is pressure times what? Volume. And the only thing that can give us this relationship is what? Work. Because when you work on work, the units of pressure and volume is the same thing as what? Work done. So the correct answer is what? Work done, which is option B. Question 29. The wavelength of the first overtone of a note in a closed pipe of length 33 centimeters is what? Option A 44 centimeters, option B 33 centimeters, option C 22 centimeters, and option D 17 centimeters. Now looking at it, what that will come to your mind is this: a closed pipe. A closed pipe is a pipe that is closed at one end. So how do we know the first overtones? The first thing is to know the overtone, the first overtone of a closed pipe, knowing that frequency is equal to V over what? Lambda, okay? But for the closed pipe is equals to 3V over 4L, right? So the whole of this is equals to what? My wavelength. So I will now say therefore 1 over lambda is equals to 3 over 4L, right? So therefore the lambda becomes 4L over what? 3. Okay, now we are not going to change this to meters because the options we have is in centimeters. So let's just solve by saying that the length is given as 33. So this is lambda is equals to 4 times 33, right? Then divided by what? By 3. Is that clear? Now if this divide this itself 1, divide is going to give me 11. So 4 multiplied by 11 is going to give me 44 centimeters. Is that clear? So that is why the correct option to this question is option A. Question 30. A boy drags a bag of rice along a smooth horizontal floor with a force of 2 Newton applied at an angle of 60 degrees to the floor. The work done after a distance of 3 meters is what? So now simply you're looking at work done in an inclined plane, and the force given in this question is 2 Newton, right? But it was inclined at an angle of what? 60 degrees, and the distance is equal to what? Let me use x, and the distance is equal to 3 meters. So how do you know the work done? The work done, W, is equals to F cos theta times what? Distance, right? So let's just substitute. My force is what? 2 multiplied by cos 60, then times what? 3. Now let's proceed. We know that this is 2 cos 60 is 1 over what? 2, then multiply by what? 3. Okay, now if this cancels this, the work is equals to 3 joules, right? So the correct option to this is option A. Question 31. Equation of wave traveling in a horizontal distance is expressed as y equals 15 sine 2 over 5 bracket 60t minus x. This is minus x, okay? Alright, what is its wavelength? We have the following options. Option A 60 meters, option B 15 meters, option C 5 meters, option D 2 meters. For us to solve this, we have y is equals to 15 sine 2 over 5 bracket 60t minus lambda. So let's open this bracket, okay, and see what we have. We have that y is equals to 15 sine, this multiplied by this is going to give us 2 times 60 is 120 divided by 5 is going to give me 24t minus 2 over 5 what? x, right? Now using a progressive wave, we have that y is equals to a sine bracket 2 pi ft minus 2 pi x over lambda. Okay, so when I equate this to this one, this is just x. Let me read it, let me change it to x, sorry. So now when I equate this one to this one, I'm going to have the value of wavelength simply by equating these two. So you have what? 2x over 5 is equals to 2 pi x over lambda. Okay, automatically lambda is equals to what? 5. And the correct option to this question is option C. Question 32. From the diagram above, the equivalent capacitance of the three capacitors is what? Option A, 1 over 3 microfarad. Option B, 1 over 9 microfarad. Option C, 1 microfarad. Option D, 3 microfarad. Effective capacitance is 1 over C total is equals to 1 over C1 plus 1 over C2 plus 1 over C3 because they are connected in series. So 1 over C total is equals to 1 over 3 plus 1 over 3 plus 1 over 3, right? The LCM is what? 3. And 3 into itself is what? 1. So I have 1 plus 1 plus 1, right? So this will give rise to what? 3 over what? 3, which is equals to 1 over C total. Okay, so even if I divide, I'm going to have this to cancel out. Okay, so my total capacitance is 1 microfarad. I hope that is clear. Now the correct option to this question is option C. Question 33. If a charge of 2 microcoulombs is situated in a field of intensity 400 newtons per coulomb, the force on the charge is what? We have the following options. Option A, 4 times 10 to the power of 3 Newton. Option B, 8 times 10 to the power of minus 4 Newton. Option C, 4 times 10 to the power of 6 Newton. Option D, 8 times 10 to the power of minus 9 Newton. If you remember that the electric field intensity E is equals to the force over what? Charge, right? So what you're looking for is the force, which is this. If I say the force is equals to electric field intensity multiplied by what? By the charge. Is that clear? So simply by substituting into what I have. So what's my field intensity? I have, so my force is equals to, I have 400 Newton per coulomb, right? Multiplied by the charge, which is 2. This microfarad, I'm going to remove it. And 1 micro is 10 power minus 6. I will now say times 10 power minus 6. Okay. Now this is going to give me 8 times 10 to the power of minus 4 Newton. Is that clear? So the correct option to this question is option B. Question 34. We have this diagram. They said, which of the following graphs shows the correct vector diagram for the circuit? We have option A. We are going to go through this and know the one that is correct. This circuit is RL circuit, okay? So the circuit goes this way. In an R circuit, the current and voltage in phase, that is IR, okay? But in inductor circuit, in this L circuit, I have that the voltage is leading what? The current, that is VL, and this is what? IL. So when I combine the two vectors together, I'm going to have that what? This is going this way. So this is what? VL, while this is what? VR, while current is flowing in this direction. Is that clear? So looking at the one that has similar thing with what I have, the correct option to this question is option B. Question 35. The magnitude of the angle of dip at the equator, option A, 360 degrees, option B, 0 degrees, option C, 90 degrees, option D, 180 degrees. So at the equator, the angle of dip is equals what? 0 degrees, but at the poles is equals 90 degrees. So the correct option is option B. Question 36. The force on a charge moving with velocity v in a magnetic field B is half of the maximum force when the angle between V and B is what? Option A, 0 degrees. Option B, 90 degrees. Option C, 45 degrees. Option D, 30 degrees. If you remember that the magnetic force F is equals to QVB sine theta, you want to know where this angle will give us half of the maximum what? Force. If you if you put this 0 here, everything is going to be what? 0. Let's try option A. But sine 0 is equals to 0, so everything here becomes 0. Okay, but option B, that is when theta is what? 90. So we have that the first is F QVB is equals to sine 90, but sine 90 is equals to 1. So we now say this is what? QVB. At this point, maximum force is obtained. Okay, but we are looking for where half of the maximum force will be obtained. So let's try when theta is 30 degrees. When theta is 30 degrees, the F is equals to QVB sine what? 30. Okay, so the F is equals to QVB sine 30 is 1 over 2. That is 1 over 2. So this is half QVB. So the correct answer to this question is option D, because we have gotten half of the maximum force. Question 37. At what frequency would a capacitor 2.5 microfarad used in radio circuit have a reactance of 250 ohms? Option A, pi over 800 Hz. Option B, 800 over pi Hz. Option C, 200 pi Hz. Option D, 2000 pi Hz. Now looking at this question, we have the capacitance C is equals to 2 micro what? Farad. Okay, and the reactance XC is equals to 250 ohms. Okay, so the formula is what? Xc is equals to 1 over 2 pi fc. So let's just substitute by saying that this is what? 250 is equals to 1 over 2 pi f, and my c is what? 2.5 times 10 raised to power minus what? 6. If I do cross multiply, my f is equals to 1 over what? 250 times 2 pi times 2.5 times 10 raised to power minus 6. Okay, then I'm going to carry this minus 6 up to the numerator to have a negative sign, and if I do that, I will have that what? My frequency is equals to, this becomes 1 million, okay, divided by 250 times 2 is going to give me 500. 500 times 2 is 1250 pi. So by the time you cancel this, the answer is going to be what? 800 over pi Hz, right? So the correct option to this question is option B. Question 38. The maximum kinetic energy of the photoelectrons emitted from a metal surface is 0.34 electron volt. If the work function of the metal surface is 1.83 electron volt, find the stopping potentials. Option A, 1.09 volt. Option B, 2.17 volt. Option C, 0.34 volt. Option D, 1.49 volt. Now from this question, we are asked to find the stopping potential, but you know that the maximum kinetic energy is also equals to 1 electron watt volt. So whatever thing we have as our maximum kinetic energy becomes the stopping potential. Since we have our maximum kinetic energy to be 0.4 electron volts, so that becomes the stopping potential. So the correct option to this question is option C. Question 39. The count rate of a radioactive material is 800 counts per minute. If the half-life of the material is 4 days, what will the count rate be 16 days later? Option A, 50 counts per minute. Option B, 25 counts per minute. Option C, 200 counts per minute. Option D, 100 counts per minute. The original or the initial number of atoms, which is what? 800 counts per minute. And we have the half-life to be 4 days. Then after 6 days, that means time is given as what? 6 days. We are asked to find the new count rate. That is, we are looking for what? N. So the formula we are going to use is N over N naught is equals to 1 over 2. So the time is given as 16 days. Is equals to 1 over 2 bracket T over what? Half-life, right? So putting into what I have, my N is what I'm looking for divided by my N naught is what? 800. This is equals to 1 over 2 bracket my T is 16 divided by what? 4, which will give rise to 1 over 2 bracket what? 4, right? So n over 800 is equals to, this is going to give me 1, then this into 4 is going to give me what? It's going to give me 16, right? By saying cross multiply, therefore n is equals to 800 over 16, which will give rise to 50 count rate per what? Per minute. So this is how we can solve this problem. The correct option to this is option A. For semiconductors to have negative temperature coefficient of resistance implies that option A, their resistance increase with temperature, B, their resistance decreases with temperature, C, they have electrons and holes at high temperatures, D, their resistance is constantly changing with temperature. Now the correct option to this question is option B. Their resistance decreases with what? Temperature. Because semiconductors have negative temperature coefficient. Do we understand? Alright. If this video was able to help someone out there, please don't forget to subscribe to this channel and turn on notifications to get notified each time I post videos. And lastly, do not forget to share until it gets to the last student that writing this exam. Now, if after watching this video I still need a review on any of the topics, just drop it in the comment section and I'll do just that. I wish you all the best in your exam. Voila!